today we speak, I'm Oleg, and my colleague Andrey we would like to talk about YDB, open source distributed SQL database. And the obvious question is, why yet another database? And as you can see, acronym YDB is exactly yet another database. And a little spoiler, because size matters. And let me explain a little bit. Within past decades, we can see that data in the world is growing exponentially. And it means amount of data, the volume, and data workloads. And all we can see about history of modern databases within past decades, that it aims to deal with the scale. So everything tries to deal with a scale problem, and we saw different approaches, like logical sharding of traditional relational databases, and a little bit later, different approaches with different trade-offs, like NoSQL databases when the scale was put on the first place, and the trade-offs was like with consistency, but we tried to solve the scale problem. And a little bit later, in 2011, Michael Stonebreaker told that developers need traditional relational database management system who deals with the scale. And with after a couple of years, there was a new term, like new SQL, who changed to distributed SQL term. Our history very similar to the history of databases. The command, the team behind the YDB in 2008 was involved in development of NoSQL key-value database called Kiwi, K-I-W-I. And in 2014, we started development of YDB. We tried to look at the whole problem of data management, data storage, as one big problem, and try to look at our product like a platform. So it started like database, and a little bit later we developed such products as monitoring, as enterprise serial bus based on YDB. After a couple of years, we saw a lot of requirements from our customers, and we released YDB as managed service at Yandex Cloud. And finally, a couple of months ago, we had an open source release of YDB, and it's available under Apache 2 license, one of the most free licenses from my opinion. When I speak about the scale, I have to talk about our numbers. So a little examples. We have multi-tenant clusters with thousands of servers per each cluster who serve hundreds of petabytes of data and thousands of databases. And within each database, we can serve millions of transactions per second. The products which works on YDB are mission critical, and quite often it's between online and real worlds, like ride-hailing, banking, different marketplaces, and it works like a platform, like data platform for different cloud providers like Yandex Cloud and Cloud.io. But let's have a look of what's inside of YDB. And Andrew, please.
Thank you. Thank you, Oleg. You need to turn it on.
Okay. I would better say microphone so everybody would hear me. So thank you. And yes, let's look inside YDB. So just a few facts about YDB. When we are talking about distributed system, distributed databases, CAP theorem comes to our mind, and I need to tell you that YDB prefer consistency in case of partitioning, in case of network partitioning. YDB supports distributed transactions, not so many system uses. And also we have a serializable isolation level for transactions. YDB is highly available. It means that most our setups are we have multiple availability zones, zone failure without interrupting user workload. We think of YDB as a mission-critical database. It means that a very important application can be run on top, and we don't need maintenance windows for this, because like our examples consist of migrating part of the cluster from one availability zone to another one without application interruption. Mostly we prefer OLTP workload, but we are changing to also support the analytical workload. We developed system from ground up in C++. It runs on commodity hardware, so we open source it, everybody can run it. And we have shared NAS architecture, which is important for modern systems. And also, concerning our physical architecture, we have a compute and storage layer disaggregated. It means that you can grow compute and storage layers separately. Just to understand what YDB is, it's just a database with more or less traditional tables. Like in many NoSQL databases, we have a primary key, and every table is sorted by primary key, so you have unique key and sorted data sorted by it. When we talk about a distributed database, it is very important that it could be automatically scaled, and so the solution to that is partitioning. We have partitions for tables. I mean that every partition is responsible for a set of, for a continuous query range, or a range of keys. And so that's how we do. And user interacts with the database by issuing SQL queries. When we're talking about distributed systems, we have a very important problem. It's a tough problem. It's a distributed consensus problem. So every system that pretends to be consistent must solve the problem. So we're talking about algorithms like Raft and Paxos. I think you know about them. And we also implemented consensus algorithm on top of our blob storage. It's a bit different from Paxos and Raft, but it still have the same guarantees. So you can think about tablet, which is a built-in block for YDB. It is responsible for some part of the data, and actually it's a stateless entity. You can run it on every compute node, and it stores its data in distributed storage in a way which is consistent and in a way that is fault-tolerant, and it writes log on update, and in case of crash failure or whatever, YDB infrastructure is responsible to run this query, to run this tablet, and to recover it from crash. So this is the logical architecture of YDB. Different layers like blob storage, lots of tablets which is responsible for system data, like scheme shard is responsible for scheme management. Later is a level of distributed transactions and distributed query processor and gPC. So we have very important things like tables after split and balancing. So it splits automatically in case of data growth and in case of load. Data growth can be even or not, because some key range grow faster than another one. So that's the support. Another important thing is distributed transaction. We have a scalable distributed transaction. It means that other system may suffer from one coordinator, and it can be a bottleneck. We have a solution for this. In case of our coordination system is scalable, we have multiple coordinators, and can have more coordinators, and lots of details here I can't speak right now. As Oleg said, we have a multi-tenant cluster. Most of our clusters production clusters are multi-tenant. We support several database modes like dedicated and serverless. Dedicated mode is just like more or less traditional. We have a common storage. We have virtual machines running compute nodes. And also we have a quite pure serverless model. What does it mean? Other system usually runs containers with an instance of database. So in case of you don't have queries on your database and it comes, you need to run a container, it takes time, at least seconds, maybe minutes or something like this. We can have this system warm because every database is a set of tablets which are running. So you can think of YDB as a platform because we have lots of applications of YDB beside database. We have implemented block devices on top of YDB. I mean that's like Amazon Elastic Block Store. It's a similar service presence in Yandex Cloud, so it's based on YDB. We have a Yandex wide Kafka replacement. Lots of services like data streams compatible with AWS Kinesis, and we have a monitoring, Yandex monitoring, which saves time series data into YDB. So you can see lots of features. I think it's not enough. We are working on more features. Of course, we have secondary indexes that are consistent and maybe asynchronous. We recently ran change data capture, which is impossible and relatively complicated to implement on top of distributed database. You can run YDB in Kubernetes cluster, in AWS cloud, mostly everywhere. So what's our plans? We have lots of plans, and I think that I have to underline two things. First of all, YDB was born in a company, in Yandex, and it was a proprietary system, so proprietary interfaces was not a problem. But now we're going to open world, and customers would like to have interfaces similar to something they knew. And so we're working on PostgreSQL compatibility. It's relatively complicated but doable, and you can replace Postgres with YDB sometime in the future. And we're also working on analytics because our customers store lots of data in YDB. It's an OLTP database, but they like to analyze data without exporting it to other analytical systems. So just HTAP is, I think that's a new future for most of systems, and including YDB. So that's almost all. Thank you very much for your attention. We have a site, ydb.tech. You can take a look at some things maybe I didn't mention in my short presentation. Thank you.
Thank you very much, Andrey and Oleg. And now to our last presentation of the day.